Hi, I'm Gokul Nair discussing our project Enhancing Visual Place Recognition with Adaptive Biasing in Event Cameras, conducted with Michael Milford and Tobias Fischer at the QUT Centre for Robotics in Brisbane, Australia. Event cameras offer great potential for mobile robot applications, but optimizing their performance requires careful adjustment of device parameters known as biases. But what are these biases? Event cameras threshold logarithm of input light intensities to generate spike trains called events. Each pixel generates these spike trains independently from each other, but only when sufficient changes in input light intensities are detected in its field of view. To do this, the pixel architecture of the event device converts input light into electrical signals using photoreceptors. But these electric currents in the pixel architecture also contain noise currents, which are present in the system but are not a consequence of the input light intensities. Particularly in dark environment conditions, this noise current dominates the sparse useful signal currents, making the resultant event output noisy when compared to the same in high brightness environment conditions. To tackle this, the device has artificial bias currents in them, which can be used to minimize the effects of noise currents in the architecture. We observed that an unbiased device in low brightness conditions produce noisy event output at a much higher rate than in high brightness environment conditions. So we use event rates as a feedback to understand when to trigger changes in the device biases. Our work introduces an online adaptive pipeline to regulate event rates, employing fast adjustments to the refractory period and, if necessary, slow changes to pixel bandwidth and event thresholds. We implemented our pipeline on a Davis 346 event camera mounted on an Agilex robot platform. For validation, we have chosen the visual place recognition as the downstream task, where the incoming event stream is compared to a prior recording in the map. Our results demonstrate significant performance improvements over the default bias settings as well as prior competing approaches. We provide our dataset comprising over 35 kilometers of traverses along with our code. Thank you for watching this video.